In this example, we're going to find a vector parallel to a given vector. So remember, two vectors are parallel if they're constant multiples of each other. So this problem is asking us to find a vector that has the same direction as the vector -2, 4, 2, but has a different length. The length is going to be 6 in this case. All right. So first off, since the vector is going to be parallel, we know it's going to be a constant multiple of that particular vector. Again, having the same direction would be parallel to that vector. It could be in the exact opposite direction. It would also be parallel to that vector. All right. So we want the magnitude of a constant times that vector to be 6 now. We want to change this vector into one that's in the same direction but now has a length of 6. We want to figure out what this constant is. All right. So using properties of our magnitude, we can pull the constant out in front. But when we pull that constant out in front, remember we have to use absolute value bars out in front. Because really what we're doing, if you think about what's going on here, remember when we do the magnitude of a vector, we square each of the components. Each of these would have a c squared in them. And when you do the square root of c squared, you don't just get c, you get absolute value of c. So that's really where that absolute value of c is coming from, and where that property of pulling constants out of magnitudes comes from. Okay, this part under the square root here is representing the magnitude of this vector. So we square each of the components and add them together. Again, we still need that equal to 6. 4 plus 16 plus 4 is 24. That simplifies to 2 square root of 6. So solving for c here, dividing both sides by 2 times square root of 6 and rationalizing, you'll get square root of 6 over 2. This is absolute value now, so really the values of c that would satisfy this are plus or minus root 2. But remember, again, we're being asked to find a vector in the same direction. Same direction means that constant needs to be positive, so we're going to use square root of 6 over 2 and get the vector negative root 6, 2 root 6, root 6.